Good evening, guys. Yeah, good evening. Enjoy. Yeah, let us wait for 2 minutes, then we'll get started. Okay, let us get started. Bhaskar engine and don't wait for you can join. So स्पीड कंट्रोल के बारे में डिस्कस कर रहा था. Speed control of DC motor. First method armature static control method. We discussed about that. And now the flux control method. Second one is flux control method. So इसमें speed you can obtain more than the base speed. Rated speed से ज़्यादा speed मिल जाएगा हमको. So how is that? N is proportional to E by 5. मोटर में V minus IA RA. अगर जनरेट हुआ तो V plus IR लेना चाहिए. So you can take this. N is inversely proportional to flux. Meaning आप flux को कम करो ये वाला value and speed get increases there. So decrease the flux. So the speed kind of increases here now. Let us see here now. I'll take a shunt motor. How are we going to? Flux can be decreased by decreasing the field current. So what I do here, field current decrease करने के लिए shunt resistance shunt field में रखना चाहिए. For example, this ये वाला IF1 है, IA1. So इसमें जाने वाला current when it speed is N1. N1 is the speed in the beginning. उसका corresponding field current क्या है? Field current is E by RSH. ठीक है। सो अभी क्या करेंगे, इसको स्पीड को बढ़ाना है। स्पीड को बढ़ाने के लिए सो फ्लक्स को कम करना, तो फील्ड करंट को कम करना चाहिए। सो हाउ द फील्ड करंट कैन बी रिड्यूस्ड? By increasing the field resistance value. So what I am doing here, extra resistance R external. This is RSH. V2, IF2, IL2 value. V is the voltage. So definitely इधर देखो IF2 का value, mathematically total voltage V है इधर, and resistance is V by RSH plus R external. RSH plus R external. So I know this IF2 is flux 2, so flux has reduced, field current has reduced here now, so the flux has reduced. Take the ratios here now. Armature current might be changed. We just need to take the ratios. N1 is proportional to E1 by phi 1 V minus KVL IA1 RA by phi 1 and N2 second speed NA1 E2 by phi 2 V minus IA2 RA by phi 2. Take the ratio. So fluxes are proportionate here now. So I can replace this with the field currents. So IF2 by IF1. So basically, this is the major expression. Major expression क्या है? Ratio लिया तो E1 by N1 by N2, which is E1 by E2, IF2 1 by IF2 by IF1. ये वाला expression है. इससे E values replace कर दिया मैंने. ठीक है? Once you obtain the IF2 value, for required speed, so इसमें substitute करो, so you get R external value. ठीक है? So overall, what is happening here now? Speed can be increased by keeping a resistance in the shunt field winding. Speed can be decreased. Speed घटेगा जब आपने resistance armature resistance में armature winding में add कर दिया. Speed of the machine का speed बढ़ेगा जब आपने resistance shunt field winding में introduce करेगा. ठीक है? Just copy this one. Flux control point. So in this speed can be increased by decreasing the field flux. Speed can be increased by decreasing the field flux. Okay. Let us solve one problem here. so that you'll understand the thing. सिंपल गेट में बहुत सारा क्वेश्चंस है इसके ऊपर. Just one problem. So what is the problem here? Shunt motor है, supply 240, line current 40, constant torque load. Shunt field resistance, armature resistance, additional distance to be to increase the speed from 1200 to 1400. So R external कैलकुलेट करना. इससे पहले प्रॉब्लम हमने किया, आर्मेचर रेजिस्टेंस में एक्स्ट्रा रेजिस्टेंस डाल दिया हमने. सो उधर स्पीड डिक्रीज करने के लिए, लेकिन ये वाला क्या है, स्पीड इंक्रीज करने के लिए. सो स्पीड बढ़ेगा इधर 1200 से 1400. So let us see solve this problem. This is asked in gate examination. Just value such as similar problem. Shunt motor. Then field resistance. So now this is IF1. IF1 is 240 by 100, 2.4 M. ये वाला 2.4 हुआ तो ये वाला कितना होगा, IA1 14, which is equal to IA1 plus 2.4. Yes, here. So IA1 will be 11.6 amp. Now इधर स्पीड कितना है, N1 इसका स्पीड 1200 है, दिया है स्टार्टिंग केस में. Now the second case, shunt motor. So I'll add extra resistance here. This is external resistance. ये वाला RSH है 100. So ये पता नहीं अभी लाइन करंट कितना है, I don't know. And this also I don't know. Voltage है ना, supply voltage is 240. Supply voltage is 240 here. Now definitely IF2 लिख सकते हैं आपने 240 by V by RSH plus R external. Directly I am writing here now 100 plus R external V by R value. Now speed, in this case speed कितना है 1400 है. And one more point is given, IA2 value के लिए hint दिया है constant torque load करके. मतलब पहला केस में T1 is K 5IA, right? K 5IA. So now you can write this one as K dash IF1 IA. So look at here now, T1 K dash IF1 IA1, which is equal to T2 is equal to K dash, so IF2 IA2. You got this point, right? Torque equal to K 5 IA. From here, this is the given point. So this is given, in fact, constant torque करके दिया है. So IF1 IA1, IF2 IA2, IF1 का वैल्यू 2.4, IA1 का वैल्यू 11.6. These two values I don't know, IF2, IA2. So you make this as equation 1. Now second equation क्या है? Speed का equation है. आपका speed का expression है ना? What are the speed expressions? N1 by N2, E1 by E2. Just now I have given. So IF2 by IF1. Substitute करो. N1 by N2. Okay, which is equal to, rather I would say N1 by N2. V minus IA1 RA. V minus IA2 RA. IF2 by IF1. Substitute करो. 1000 by 1200. 240 minus IA1. 11.6 RA is 1. 240 minus IA2 is unknown. RA1. IF2. Second value I don't know. IF1. 2.4. So two expressions है हमारे पास. Second equation. दो अननोन से हमको क्या चाहिए? R external additional resistance कितना रखना, उसके लिए IF2 चाहिए. IF2 जब हमको IF2 मिलेगा, R external वैल्यू पता चलेगा. ठीक है. सो अभी क्या करना, क्या ये दोनों को सॉल्व करो. सॉल्व 1 and 2. Solve 1 and 2. Get me only IF2 value. IF2 value count करो. Can you please try it? तो क्या करना अभी, इधर IA2 है ना, इधर IA2 का वैल्यू कितना है, इसका वैल्यू बताओ 2.4 into 11.6. Then substitute here now. नीचे वाला expression में आप substitute करो. So let me do that here. 2.4. So 27.84 here. 27.84 by IF2. So ये वाला वैल्यू इसमें सब्स्टिट्यूट करो, IA2 में सब्स्टिट्यूट करेगा तो आपको IF2 के लिए सम क्वाड्रेटिक इक्वेशन मिलेगा. सो वो वाला सॉल्व करो. IF2 वैल्यू कितना आएगा? Please do that. I'll give 2 minutes time. I know the answer, so can you just please finish it up? Please try yourself, because I mean these questions you have to do solve in the gate. Gate में तो करना है. We'll solve the gate questions anyway. Once this syllabus is done, machine DC machines. आज और मतलब कल आज खत्म नहीं होगा, कल तो खत्म हो जाएगा डीसी machines. So पहला घंटे में last 1 hour let's see the gate problems. So anyway, the value will be, I don't know if you have done, so around, let me move on. So 2.02 amps, so field current पहला 2.4 है, तो कम होना चाहिए, around 2.2 amps. Once you get IF2 value, ये वाला substitute करेगा. So मान लो आप 2 ले लो. So if you take the 2 here, now R external चाहिए. Question is to get the R external. So take this 2, 40 by 100 plus R external. So this will be around, I think, any answer? So somebody was saying. So anyway, IF2, yeah, IF2, yes, around Ajal Gupta, that's correct, around 1.977, and you have to take not this much, 0.1 is too much reduction. So ये मत ले लो. So आप लेना चाहिए nearer to the whatever the value you have. 2.1 से नजदीक पे 1.9, that is around 2. So R external होगा around 17 ohms, 17 or 18, something like that, right? So let me move on to the next one. So flux control method, this is what. So speed can be increased with the flux control method. The third one is we have a voltage control method, right? How do you do that? Let us see here now. Third one is kind of, we have separate system for this, like a Watt Leonard speed control method. इसमें क्या करेगा? Let us see here now. इसमें all combinations will do that here. What is happening here? Let us see. I have a generator. Okay, this is the motor, which where you want to control the speed. Motor के लिए input generator चाहिए. This is the one. Motor separately exited. This is a motor and generator. And generator also will have separately exited. Separately exited means supply separately देना. It is externally देना पड़ेगा. So this is where I am giving. So this is the place I am giving the supply. So this is the field current of motor IFM, field current of generator, armature current generator. You are getting armature current motor. Motor के लिए input generator, ठीक है, generator आ रही. And for the generator, what is the input here now? Generator कैसे rotate होगा? Generator rotate होगा जब आपने इसको prime mover से connect करेगा. And what is the prime mover here now? Induction motor. This is an induction motor. And for the induction motor, we require a 3-phase supply. Look at the setup here now. इसको speed control करना है, इस separately excited motor के लिए, right? To operate this motor, I require a generator, क्योंकि motor के लिए electrical input आना चाहिए, electrical input देना चाहिए. लेकिन generator के लिए, generator में voltage आने के लिए mechanical input होना चाहिए. Mechanical input induction motor से आ रहे. इंडक्शन मोटर के लिए इनपुट है 3-phase सप्लाई. ठीक है, तो कॉस्टलियर इक्विपमेंट है, कॉस्टलियर सेटअप है, सेटअप ज्यादा है. So now I'll include this R external of motor, and here also I have a R external of generator. What I am doing here now, ये वाला case में first one, I am going to get a speed less than a base speed. How are we doing here now? By voltage control method. What we do, voltage of a motor. मोटर को लिए वोल्टेज इनपुट कम करना है, मतलब जनरेटर का वोल्टेज कम करना है, जनरेटर आउटपुट का वोल्टेज कम करना, जनरेटर वोल्टेज कम करना. So E equal to V here now approximately, I would say here now IRA, which is equal to ZP phi N by 60. तो कैसे कंट्रोल कर सकते हैं यार इधर? So by changing the speed, but speed of induction motor is difficult. So by decreasing the excitation, देखा इधर. So meaning here now, by decreasing the field current of a generator, how can be done here now? R external जनरेटर को इंक्रीज करो. By decreasing the field current of generator, flux of a generator can be decreased. So then E or V decreased, so the speed decreased here now. So by decreasing the supply voltage decrease karo, that's what the voltage control method, then motor ka speed can be kind of reduced here. When V of a generator can be decreased, motor speed can be decreased. Mention that point. Speed can be reduced by the motor. Speed of the motor can be reduced. Speed of the motor can be reduced by decreasing the supply voltage, by decreasing the generated voltage of generator, by decreasing the generated voltage of the generator. Voltage can be decreased by decreasing the generator excitation. Voltage can be decreased by decreasing the generator excitation. Second one, n less than base speed. ज्यादा स्पीड मिलेगा हमको कौन सा कंट्रोल है? Flux control. Your voltage control is analogous to, have you seen here now? This is analogous to rheostatic control method. Do you agree with me? आर्मेचर rheostatic control method हमने क्या किया? Additional resistance आर्मेचर में include कर दिया, उस समय मोटर का स्पीड कम हो गया. Instead, what we are doing, supply voltage itself is reduced. Supply voltage to the motor itself is reduced, so that motor का speed कम हो जाएगा. दूसरा क्या है? Flux control. What are we doing here now? Excitation of motor. R external motor increase करो, R external motor increase करो, ताकि field current IFM is decreased and the speed of the motor is increased. So by decreasing the excitation of motor, speed can be increased. Mention that point. By decreasing the excitation of the motor, by decreasing the excitation of the motor, speed can be decreased. I'm sorry, increased. By decreasing the excitation of motor, speed can be increased. बढ़ेगा, speed बढ़ेगा इधर. Not only that, yeah, advantage less आएगा, speed all the wide ranges, less than the base speed, more than the base speed. और not only that, third one क्या है ये वाला टेक्निक में वॉड लेनर में, reversal of the speed, reversal of rotation of motor. कौन सा मोटर है? डीसी मोटर है, नॉट द इंडक्शन मोटर. इसको कैसे रिवर्स कर सकते हैं? टॉर्क को रिवर्स करना, टॉर्क इज प्रोपोर्शनल टू phi Ia. So now what I can do, by reversing the excitation of the, देखा इधर, by reversing the excitation of the motor, flux can be minus, or you can see here now, minus phi Ia, or you can have phi minus Ia. Anything you can do. So then speed will be reversed. The rotation opposite में आ जाएगा, क्योंकि टॉर्क opposite में आ रहा है. ये कैसे कर सकते हैं? फ्लक्स को opposite by interchanging the motor excitation. करंट को कैसे रिवर्स कर सकते हैं? By interchanging the generator excitation. but not the both को मत करो, दोनों को मत करो, माइनस माइनस हो जाएगा, प्लस आएगा, सेम डायरेक्शन में जाएगा. So reversal of the motor can be done by interchanging the excitation terminals of motor or generator, but not both. Please mention that point. Rotation of the motor can be reversed. Rotation of the motor can be reversed. Rotation of the motor can be reversed by either interchanging the excitation of motor terminals, either interchanging the excitation terminals of motor or generator, but not both. Okay, that's about the Watt layout system. इसमें क्या है? All possibilities are there, right? Speed less than base speed, more than base speed. There are two terminologies here now. Something called as a constant torque and constant power drives. What do you mean by that? Constant torque versus constant power drives. So wide variation speed, let us see here now. This is speed, your torque or power, मान लो. So this is speed is base speed. I would say here now NB. Left side is N less than P. NB. Right is N greater than NB. Clear? So if you remember, when that speed is less than NB, what is the control we use? What is the speed control we are doing? Voltage control. Or this is armature rheostatic control. ठीक है? And right side में कौन सा control है ये वाला? Speed greater than base speed. ये वाला flux control. When less than this one, we have seen if it is a constant torque load, torque is going to be constant here. Now this is a torque. Because we have already seen voltage control method में torque equal to K phi IA. Flux is not going to change anyway here. Your flux change नहीं हो रहा है. तो आर्मेचर करंट भी कांस्टेंट है क्योंकि कांस्टेंट टॉर्क रखा तो ये भी कांस्टेंट है. फ्लक्स आई मीन अगर स्पीड मोर देन द बेस स्पीड के लिए फ्लक्स कंट्रोल यूज कर दे तो टॉर्क क्या हो गया? व्हाट विल हैपन? टॉर्क स्पीड मोर देन द बेस स्पीड के लिए हम करना क्या? फ्लक्स को कम करना चाहिए. सो टॉर्क हैज टू काइंड ऑफ डिक्रीज हियर नाउ. सो टॉर्क विल बी डिक्रीज्ड हियर नाउ. दिस इज द टॉर्क. Power which is equal to E into IA. I know. वोल्टेज कंट्रोल मेथड में क्या करें? इनिशियली वोल्टेज 0 हुआ तो पावर 0 है, स्पीड 0 है. So when the speed increases, meaning when the voltage increases of the generator or the voltage input to the motor increases, power increases linearly, then speed is going to increase, meaning starting from 0. So then power is kind of increased here now like this. And then once this base speed is obtained, flux control method mein look at here now, your power is going to be constant. Why the power is going to be constant? Let us see here now. Power can be written as I mentioned here now, E into IA ZP 5N by 60A IA. Flux control method में what are we doing here now? Flux control method में flux को कम कर रहे ताकि speed increase होगा. So E is a constant. So that I is a constant. So in this case, constant power में drive में E fixed है वाला. So armature current is also constant. If power is fixed, armature current drawn by the motor is also constant. So the conclusions क्या है here now? In the flux control, in method flux control method, if constant power drive is used, if constant power drive is used, IA is constant, armature current constant है. एक point. Second point क्या है? Voltage control method में, this is in this method, voltage control method, armature rheostatic control method. If constant torque is used, if constant torque load is used, IA is constant. समझ गए बात? That's what we are doing here now. So voltage control method में मतलब overall what we're trying to say here now, constant torque drive is preferred for the voltage control method, constant power drive is for the flux control method. अगर उल्टा कर दिया आपने, मतलब flux control method में constant torque use कर दिया, तो armature current is kind of increases here now. This is what I was saying. You know, look at this. अगर ये वाला constant torque वाला use कर दिया तो what will happen in this constant torque? T equal to, this is what I was saying, constant torque use कर दिया flux control में. Flux control method में flux को कम करना चाहिए, लेकिन T constant रखा तो IA increase होगा, armature current बढ़ेगा. समझ में आ गया ना? So voltage control method में कौन सा drive और कौन सा टेक्निक यूज करना, कांस्टेंट ड्राइव या फिर कांस्टेंट टॉर्क या कांस्टेंट पावर वाला यूज करना. ठीक है, कांस्टेंट टॉर्क वोल्टेज कंट्रोल में यूज कर दिया तो आईए भी कांस्टेंट है. ठीक है, अगर फ्लक्स कंट्रोल मेथड में कांस्टेंट पावर ड्राइव यूज कर दिया तो आईए कांस्टेंट है. अगर आपने फ्लक्स कंट्रोल मेथड में कांस्टेंट टॉर्क यूज कर दिया तो ठीक है, you can see here now armature current increases here, right? Yeah, please copy this one. If constant torque load is used, IA is constant. Flux control method, if constant power drive is used and armature current is constant. Otherwise, armature current increases. You can mention that. Okay. Let us move on to the next one. This is about the speed control. We'll solve the gate questions. I told you tomorrow we'll solve it. First, let me finish this DC machine. So next topic क्या है इसमें? ब्रेकिंग है, मतलब मोटर को ब्रेक करना है. ब्रेक मतलब रोटेट हो रहा है, उसको बंद करना है. वो तो कैसे करेगा? मतलब मान लो ट्रेन जा रहे, ट्रेन 60 किलोमीटर में जा रहे, तो आपको स्पीड कम करना चाहिए. स्पीड कम करने के लिए ब्रेक लगाना पड़ेगा. ठीक है, कौन सा ब्रेक है? व्हाट आर द टेक्निक्स आई हैव इन द मोटर? So I told you already, braking matlab two things it has done. One is to stop the motor at a desired position. See, it is not that whatever the position, अगर मान लो आपका बाइक का सिनेरियो है, बाइक में क्या टू व्हीलर इसको बंद करना है, मतलब अगर मान लो अपने इंजन को पुट ऑफ कर दिया, बंद कर दिया, तो मोटर बाइक बंद हो जाएगा। लेकिन ब्रेकिंग का मतलब क्या होता है, जहां पे रोकना है उधर रोकना चाहिए, ऐसा नहीं कि मतलब थोड़ी देर बाद थोड़ी आगे जाके रोकेगा। इट्स नॉट द केस। सी ब्रेकिंग मीन्स इट शुड स्टॉप एट डिजायर्ड पोजीशन। स्टॉप भी नहीं है ब्रेकिंग के लिए, कभी कभी क्या ट्रैफिक में आप क्या करेगा, सो टू रिड्यूस द स्पीड ऑल्सो we reduce the speed also, speed of motor. So दो चीज करेगा ब्रेकिंग का वजह से, one is to stop the vehicle को स्टॉप कर सकते हैं हम ना, मोटर को स्टॉप कर सकते, बंद कर सकते। दूसरा चीज क्या, रिड्यूस द स्पीड को कम कर सकते ब्रेकिंग का चीज। और मोर ओवर क्या कर रहे हैं अपने मैकेनिकल बाइक का सिनेरियो में, क्या कर रहे हैं, अपने ऑपोजिट टॉर्क अप्लाई कर रहे हैं ब्रेकिंग में। So braking torque is always opposite the electromagnetic torque. For example, motor is rotating with the K phi IA. So braking torque क्या हो गया? Braking torque is always opposite. Torque आप opposite में apply करना चाहिए. So what I can do? Either minus phi IA or TB braking torque is K phi minus IA. Normally आर्मेचर करंट को इंक्रीज करेगा, अपोजिट करेगा, मतलब चेंज करेगा। ये दोनों इक्वेशन देख लो, TE is opposite to TB, electromagnetic torque and braking torque. TE is, we know this one. Electromagnetic torque, and TB is kind of braking torque. TB is braking torque here, no opposite है। लेकिन देखा अपना आर्मेचर करंट को माइनस में, व्हाट इज दिस यार, IA पॉजिटिव इज ए मोटर, करंट ऑपोजिट डायरेक्शन में जाने तभी हमको ब्रेकिंग टॉर्क आएगा, तो जनरेटर। तो मींस व्हाट आर द ब्रेकिंग टेक्निक्स, हमने जो भी ब्रेकिंग टेक्निक्स अभी कर रहा हूँ, मतलब अभी डिस्कस करेंगे, ऑल ब्रेकिंग टेक्निक्स विल मेक द आर्मेचर करंट नेगेटिव, मतलब जनरेटर एक्शन। So motor has to be placed in generator mode to apply the brakes. All braking techniques makes the motor to operate in generator mode to apply the braking. Please mention that point here now. In all braking techniques, motor has to operate in generator mode. Motor has to operate in generator mode. That is current opposite direction. That is bracket में आप रख देना, current in opposite direction. Now, what are the techniques here now? Techniques क्या है? Braking techniques. First one is plugging. What we do in the plugging here now? For example, shunt motor ले लो. Okay. So this is what, let me see, draw that direction. This is the motor mode. Then braking mode में plugging क्या हो रहा है? So what I'm doing here now, A1, A2, F1, F2 terminals I'm representing. So current क्या है? आर्मेचर करंट कैसे जा रहा है? A1 to A2 जा रहा है. This is how the current is going. ये braking mode में क्या चल रहा है? So I'll do the same thing. Field winding is intact. Armature winding. A1, A2. इसका करंट चेंज होना चाहिए. Look at here now. Armature current minus होना चाहिए. Opposite direction में जाना चाहिए. We are not changing anything from the supply. Same supply, same current here now. IL. Only thing is, I'm just changing the terminals. What are we doing here now? So how the current is going? So armature current supplies आना चाहिए ना? This is how the current going. Now the current is, look at here now. This is our armature current. Previously A1 to A2 armature current, now A2 to A1 armature current direction changed. So what will happen? Here electromagnetic torque is K phi Ia. Here braking torque is K phi minus Ia. Okay? So torque opposite में आ रहे. So how the torque is opposite? Let me show it for you here now. For example, field direction is still same. Internally, what is happening? North and south. For example, armature current. This is into the plane, out of the plane armature current, and then rotation is going. कौन सा डायरेक्शन में जाएगा? मोटर है ना. So मैंने Fleming's left hand release करो torque के लिए. 4 finger field direction, center finger inside. So rotation, इसका rotation is T. This is the T electromagnetic torque direction. Rotation. Braking में क्या होगा? आपने current का direction change कर दिया. तो what is the torque is acting here now? Look at here now. This is the field direction. Field poles are same, but the current direction has changed. So then what will happen? Rotation will not start, but opposite. The torque which is acting is opposite to the electromagnetic torque. This is what is called braking torque now, which is applied. What is happening is speed जा रहे हैं ना, तो आप braking torque apply करें. पहले मान लो 60 किलोमीटर पर आवर है. अभी 40 आएगा, 30 आएगा, 20 आएगा, 10 आएगा, 10 आएगा, 0 आएगा. 0 आने के बाद आप सप्लाई को डिस्कनेक्ट करना. अगर सप्लाई को डिस्कनेक्ट नहीं किया तो ये वाला मोटर ऑपोजिट में रोटेट हो जाएगा. 0 जाए 0, -10, -20, -30 ऑपोजिट डायरेक्शन में रोटेट हो जाएगा. ठीक है, which is not acceptable here now. So the disadvantage of the plugging is here now. Only one thing: once the motor is obtains 0 speed, supply has to be disconnected. Otherwise, motor rotates in the opposite direction. Okay, that's a disadvantage here now. Moreover, what is the volt? Yeah, please mention that point. Disadvantage of plugging. Disadvantage of plugging. Disadvantage of plugging. Once the motor applies 0 speed, obtains 0 speed, supply has to be disconnected. Supply has to be disconnected. Otherwise, motor rotates in opposite direction. Motor rotates in opposite direction. Second one, second disadvantage. I'll tell you the second disadvantage here now. During plugging, very high amount of braking current is flown. How very high amount of current is flown? Let us see. Either armature current, I know the motor of armature current IA, which is equal to B minus E by RA, equation I know. So current is going from in this direction IA. So now what is happening? Terminal voltage is changed. Polarities are changed here now. Plus mono either voltage here. So now the direction has changed, current direction. So it becomes armature current or the braking current. ये वाला case में minus B minus E RA. This is very high value of current, braking current or the armature current now. So इसको control करने के लिए what I do here now, one R external is kept here now, so that your braking current is this is there is a gate question here now, RA plus R external. So to control the braking current in plug-in, external resistance should be added, and that external resistance creates a losses here now. Please mention that point. Please mention that point. To control the high braking current in plug-in, to control the high braking current plug-in, external resistance is added. External resistance is added. In which heat is generated. In which heat is generated. That is, kinetic energy is converted into heat energy. That is, kinetic energy is converted into heat energy. Another point, one more point. What is the voltage here? Armature resistance में voltage कितना है अभी? IA RA. What is the voltage here now? Applied across the armature resistance. IA RA. IB मतलब IA only here. So during plugging, voltage across the armature resistance is V plus E approximately. Next point you can mention. Voltage across the armature resistance during plugging. This is what I was saying. IB RA is equal to magnitude V plus E. Voltage across the armature resistance during plugging is V plus E, approximately 2V. Approximately 2V. Okay. ठीक है, the disadvantage मैंने क्या बताया? जब आपने सप्लाई को डिस्कनेक्ट नहीं किया तो मोटर ऑपोजिट डायरेक्शन में रोटेट हो जाएगा. सो वी हैव टू बी केयरफुल. ये वाला डिसएडवांटेज नेक्स्ट मेथड में एड्रेस कर दिया. सेकंड मेथड क्या है इधर? डायनेमिक ब्रेकिंग. So what we do in the dynamic braking here, first let me see in the motoring mode. This is IL. Now what I do in the braking mode, here also armature current, see look at here, armature current is going like this, this is IA. In all the cases armature current has to rotate in opposite direction. So इधर क्या करेगा देखो, फील्ड वाइंडिंग को डिस्कनेक्ट करो, मतलब आर्मेचर वाइंडिंग को डिस्कनेक्ट करो फ्रॉम द फील्ड. So this is armature. what will happen, रोटर को आपने डिस्कनेक्ट कर दिया, लेकिन क्या है, ये रोटर डिस्कनेक्ट कर दिया, थोड़ी देर बाद बंद हो जाएगा, बट दैट इज नॉट कॉल्ड एज ब्रेकिंग, क्योंकि डिजायर्ड पोजीशन में ऑफ नहीं हुआ. इट इज समथिंग लाइक आप फैन को बंद करना है, आपने स्विच ऑफ कर दिया, तो 1-2 मिनट तो रोटेट हो जाएगा, उसके बाद बंद हो जाएगा फैन, बट वी आर नॉट अप्लाइड एनी ब्रेक, समथिंग लाइक दिस. लेकिन हमने डिजायर्ड पोजीशन में, मतलब रिक्वायर्ड पोजीशन में, रिक्वायर्ड टाइम पे इसको बंद करना है, इसलिए मैं क्या कर रहा हूँ, डिस्कनेक्ट करने के बाद एक रेसिस्टेंस, एक्सटर्नल रेसिस्टेंस कनेक्ट कर दिया है. So what will happen here now? A1, A2, current is flowing now, A1 to A2, motor is still rotating the same kinetic energy. So the current going will be, direction of the current is getting changed. Look at here now, in this case. Braking mode is nothing but it is acting as generator. Current ka direction change hoga. How it is changing, let us see here. This is what actually inside happening. Rotor is here. Mono current is into the plane, out of the plane. So the torque is here now. Forefinger, field direction left hand. The current is inside. So the torque is going. This is how the rotation. Electromagnetic torque rotation. FLH use करो. अभी क्या हो रही है, आपने फील्ड करंट को डिस्कनेक्ट नहीं किया तो पोल्स विल बी स्टिल देयर. इसका सप्लाई को डिस्कनेक्ट कर दिया, यू हैव डिस्कनेक्ट द सप्लाई, सप्लाई को डिस्कनेक्ट कर दिया, तो अभी क्या हो रहा है, स्टिल इट इज रोटेशन. रोटेशन कैसे होगा, स्टिल द रोटेशन इज इन द सेम डायरेक्शन. दिस इज द रोटेशन. डिस्कनेक्ट कर दे, फैन को बंद कर दे, फिर भी वही रोटेशन तो वही होगा. Then what is happening, you are a generator, rotating conductor placed in magnetic field. अभी रोटेट हो रहे, किसका वजह से, rotation due to kinetic energy. Rotation due to kinetic energy. Kinetic energy का वजह से half m square का वजह से रोटेट हो रहे. Rotation is not because of the supply, not because of the TE. Rotation is due to kinetic energy. When the conductor is placed in a magnetic field, what will happen, EMF is generated. So what is the EMF direction here? If we find use the EMF direction here now, EMF or current direction by using Fleming's right hand rule. So then this current is into the plane, out of the plane here now. When the current is like this, now this is the current, IA, opposite direction में आ रही, A2 to A1. This is IA. So then what is the torque here now? Then the torque will be in the opposite direction. This is how the torque is acting, braking torque, this is in fact. So after some time, or if the R external is increased, so entire kinetic energy is converted into heat energy, then and motor gets stops here. So that way, once the motor stops, even supply is there, nothing will happen. So please mention that point. In this method, supply is armature is disconnected from the field winding. Armature is disconnected from the field winding. Armature is disconnected from the field winding, and the field winding is intact with the supply. Field winding is intact with the supply, and armature winding is connected with the external resistance, closed with external resistance. Armature winding is, or armature circuit is closed with external resistance. Next point, due to kinetic energy of rotor or armature, due to kinetic energy of rotor armature, it continues to rotate in the same direction. It continues to rotate in the same direction. But current induced is in opposite direction. Current induced in opposite direction. Which generates opposite torque. Which generates opposite torque. Okay. Yeah. You can mention here now EMF or current direction by FRH, Fleming's right hand rule. You have a generator action. This is a motoring action. This is generator action. Current direction change होगा. Braking is nothing but generator action में operate कर रहे हैं. But इन दोनों में kinetic energy waste हो रही है in the form of heat. तो क्या करना? The next method में what is called as a regenerative braking. What is called regenerative braking, and both these energies, whatever the energy which is wasting in the form of heat, that can be addressed here. तो इधर क्या कर रहे हैं? ये वाला मेथड में स्पीड जीरो नहीं होगा. You cannot make the speed zero, but speed can be reduced. कैसे reduce कर सकते हैं? For example, आपने मतलब आपका ट्रेन है, गाड़ी घाट रोड में आ रही, घाट और हिली एरिया, माउंटेन से ऊपर से नीचे आ रही गाड़ी, तो आप क्या करेगा? आप ब्रेक अप्लाई करेगा, ब्रेक अप एक्सेलरेशन मत देना, एक्सेलरेशन मत देगा, ब्रेक अप्लाई करेगा, फिर भी still what will happen? It's keep on kind of coming down. You don't give the acceleration, but why it is coming? Why? Because here it has mgh, potential energy is maximum and kinetic energy is zero here now, and in at end it reaches here now, potential energy is zero and kinetic energy is maximum of mv square. Mgh is the h is zero here now. In between it has both potential energy and kinetic energy vehicle. So what I am saying here now, मैं क्या बोल रहा हूँ इधर? Voltage normally क्या current क्या होना चाहिए? Current in a motor V minus E by RA. अभी ब्रेकिंग में क्या होना चाहिए? माइनस IA होना चाहिए. माइनस IA कैसे आएगा यार? Provided E will be more than V. E when it will be E more? E will be more when the speed is kind of more. When the speed will more, इधर देखो speed कैसे आएगा more? ज्यादा कब आएगा? हिली एरिया में स्पीड ऑटोमेटिकली ज्यादा आ जाएगा. So E will be more, then current is in opposite direction. Current is not flowing in the opposite direction. ये वाला जो भी current बाहर आ रहा है, now the motor is acting as generator. So this is supplying this current to other parts of the train, like light, fan, and tube light, whatever it may be. So regenerative braking वो wastage नहीं है. You are not stopping the vehicle. Vehicle को बंद नहीं कर सकते, stop नहीं कर सकते, लेकिन speed को control कर सकते हैं. Energy जो भी energy extra आया because of this kinetic energy, E can be increased. Current is negative, so that current is fed back to the supply. So please mention that point. In regenerative braking, speed of the motor can be reduced, but cannot be stopped. The additional energy which is obtained by is fed back to the supply, is fed, 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 is fed back to supply. That way, no wastage of energy is obtained in this method. No wastage of energy is obtained in this method. Okay. Okay, then last topic, yeah, braking is done. There is a last topic in this one is efficiency of DC machine. Efficiency of DC machine. Machine means it can generate and motor. When if it is a generator efficiency here, output upon input. Generator हमको क्या पता चलेगा? Output. I know electrical quantity. Input mechanical quantity. So output plus loss, I will make it here. If is motor, of course in 200. If it is motor, same definition. But motor case में क्या पता चलेगा हमको? Input is electrical quantity which we know it. So output के लिए input जो भी देगा, so losses subtract करना. So we get this. So here losses are there. So what are the losses it has, machine has? So let me write it here now. First, I'll give the complete chart here now. Please copy this one. And most of the things we have already discussed transformer में. So constant loss. Yeah, I'm sorry. All losses are complete one. Yeah, all the losses, constant losses PI and variable loss PC. You already देख लिया है transformer, but I'm just summarizing here now. क्योंकि DC machine में और थोड़ा ज़्यादा losses होता है. Transformer का losses हमने क्या देखा है? Transformer में iron loss देखा, मतलब ये set देखा और copper losses देखा. That's all. nothing else. Iron loss and copper losses, no other losses we have discussed. Okay, major losses those are. लेकिन इधर डीसी मशीन में मतलब ये वाला रोटेटिंग मशीन है ना, सो इसका मैकेनिकल लॉस होगा, फ्रिक्शनल लॉस मतलब मैकेनिकल में फ्रिक्शन लॉस, ब्रश फ्रिक्शन मतलब ब्रश इज केप्ट ऑन द कम्यूटेटर, ब्रश इज स्टेशनरी, कम्यूटेटर इज रोटेटिंग, सो इन दोनों के बीच में फ्रिक्शन होगा, so some drop will be there. Bearing friction, so for the support of this machine we need some bearings. Copper loss, we know stator and the rotor. In case of DC machine, stator क्या है, कौन सा stator क्या है वाला, field winding is stator, rotor is armature. Steel wool loss, copper steel wool loss मतलब due to skin effect, copper steel wool loss. This is something extra. So due to skin effect, you know the skin effect here, no? Current is flowing on the surface of the conductor. Current is flowing on the surface of the conductor. So R effective, RAC is greater than RDC. So इसका एक additional resistance का वजह से more loss हो जाएगा. That's called as copper steel wool loss. Core steel wool loss is nothing but due to unequal distribution of the flux density and losses are kind of increased. I told you in the armature reaction में iron losses are more. क्यों? Flux density waveform unequal distribute हो गया. Trailing pole tip में ज़्यादा है, leading pole tip में कम है. Similarly here also core steel wool loss का मतलब and flux density waveform is not symmetrical. ठीक है? Those are the things. ठीक है? Just copy this. सब कुछ पता है, but you copy this one. Copper steel wool loss. एक point लिख देना, copper steel wool loss. Yeah, since alternating current is flowing inside the armature of DC machine, core steel wool loss के लिए. Since alternating current is flowing inside the armature of DC machine, its effective resistance RAC, its effective resistance RAC is more than, its effective resistance RAC is more than RDC. Hence, losses are more. Okay. Next, core steel wool loss. Core steel wool loss. Due to unequal flux density waveform, due to unequal flux density waveform, more losses are generated. More losses are generated, called as core steel wool loss. Okay. Yeah, remaining all are, you know it. I hope you copied. Windage. Wind means because of wind. Hawa. Opposite में हवा आई तो loss ज़्यादा होगा. When machine is rotating, there is some wind in opposite direction. Copy कर दिया आपने? Shall I move on? The last topic is left, Swinburne's test. If that is done, DC machine will be over. Just let me know if I need to move on. Is it done? Copied? Shall I move on?
Yes, sir.
Okay. So now there is a Swinburne's test to find the efficiency. So how do you do that? Swinburne's no load test. Yeah, it is only on the shunt motor. Not be performed on the series motor. The series motor and no load. No load में operate कर दिया तो क्या होगा? Series motor will run at high speed, very high speed. So what we are doing here now in the Swinburne's test. In the supply, okay, to shunt motor and let it run IF and IA. So now what are you doing? You just keep a voltmeter here now, connect, and then ammeter. You can keep one ammeter here now. You can keep another ammeter if you want. So what are the readings I am obtaining here now? Input to the armature. This is A1 module, IA0. So input to armature, which is B into IA0. ये वाला current है ना, IA0 पता है हमको. We know this current here now, which is IA0, and armature को input दिया. So what it is doing here now? It has taken, no work is being done. Motor क्योंकि mechanical load connect नहीं किया motor को. Then why the IA0 is taken? क्यों motor current ले रही? अगर आपने लोड नहीं कर रही, लोड कैरी नहीं कर रही तो क्यों ले रही है? जो भी करंट आर्मेचर लिया इधर, and that is being converted B into IA0. That input is being converted into losses. कौन सा losses होगा? Small amount of copper losses IA0 square RA. आर्मेचर में कौन सा losses होगा यार? Iron losses I have PI and friction and windage losses. So PI and PFW can be calculated from this data. IA0 I know because V I know, IA0 I know, RA भी calculate कर सकते हैं आपने by using a DC test. So VIA0 IA0 square RA under no load we have obtained. Iron loss, friction loss ये वाला constant loss है. There is one more point, constant loss का है शंट वाइंडिंग में और शंट मोटर में इसका मोटर का करंट भी पता चला हमको. This is RSH. So shunt field losses also either you can calculate V into IF or you can say here now IF square RSH. So ये भी constant है. Shunt field losses also constant, although हमने variable losses के नीचे लिखा like stator and rotor. Rotor तो variable है IA square RA. Stator, which is a field, IF square RA, IF square RSH is a constant. So total constant losses in machines, say maybe PK, I would say, what will happen here now? PI, PIFW plus and shunt field losses, say PSH. So, okay, then what are the other losses left here? Either constant losses मिला, variable losses क्या है? Variable losses will be no load पे नहीं है. Now what we can do, अगर आप मान लो efficiency चाहिए, for example, I want to get the efficiency at a current, efficiency at a current I, say for example, say 100 amps. तो efficiency कैसे लिखिएगा? Percentage of efficiency is output upon input into 100. So whatever it may be, generator motor, ये वाला केस में motor है, तो input पता है, so input V into IL minus loss. Loss is PK plus PV, variable loss, constant loss, and your input is V into IL. लेकिन ये constant losses हमको no load में मिला. See, that's what I was saying. Constant losses are constant irrespective of the load, irrespective of the speed. No load में जितना irrespective of the load, in fact. So no load में कितना losses मिलेगा, constant losses, वही losses load पे भी मिल जाएगा. This is under load. We are actually calculating the efficiency under load by finding the constant losses under no load. क्योंकि no load losses can be calculated from the no load test. So under load may PK plus PV, and you can substitute here now. V into IL minus PK का value, I know this. And what is PV? इसमें PV क्या है? Variable loss here now. So this is where PV is IA square RA. In this case, IA equal 100. I know everything. Substitute it down. So Swinburne's test में मोटर को नो लोड में ऑपरेट करके कांस्टेंट लॉस कैलकुलेट कर दिया. These constant losses are used when the machine is loaded. Machine is actually load नहीं किया, but virtually you are saying 100 amps आया तो efficiency कितना आएगा virtually calculate कर रहा हूँ. Since you are not loading the machine actually 100 amps पे, we don't know the heating effect, temperature rises, वो हमको पता नहीं चलेगा. ठीक है, इसलिए one of the disadvantage of the Swinburne test is, since the machine is not being loaded, we are not able to find the heating effects, temperature rises of the machine. That's one of the disadvantages of the Swinburne test. So please copy this one, Swinburne test 1 point. It's a no load test. It's a no load test. Shunt motor is operated under no load. Shunt motor is operated under no load. To find the constant losses. To find the constant losses. These losses are always constant irrespective of the load. These losses, constant losses, are constant always irrespective of the load. and this value is used in the these losses are used in the calculation of efficiency. These losses are used in the calculation of efficiency of machine if it is loaded, when it is loaded. You can say when it is loaded. This is actually our question. Efficiency at IA equal to 100 amps of load, some current. Just an example I have given. So I will calculate this way. PV is, yes, we know how IA, PK can be obtained from the no load test data. This is PK. Copy current. So if you are copied, mention disadvantage of synchronous test. And if you are copied it or not. Stray load losses cannot be calculated from this test. Stray load losses. We are missing stray load losses. Only variable losses लिया, constant losses लिया. Variable loss में I square RA लिया, लेकिन all stray load losses miss कर दिया. क्योंकि I don't know how to calculate. Stray load losses cannot be calculated from this test. Hence, the efficiency calculated is more than the actual efficiency. Hence, it is optimistic method to find efficiency. Hence, this method is optimistic. Hence, this method is optimistic to find the efficiency. Okay. Second disadvantage, since the machine is not loaded actually, hence heat rises hence temperature rises and heat generation. Temperature rises and heat generations are not considered. And this test cannot be, next disadvantage, this test cannot be performed on series motor. This test cannot be performed on series motor. What will happen? If it is performed, it catches very high speed, you can mention. If motor is operated under no load, if motor is operated under no load, it catches very high speed. Okay. Okay, fine. With this, it is done. Machines is done. DC machines, in fact. And tomorrow I'll stop here. If you don't have any doubts, so far, if you have any doubts in transformers, DC machine, दो topics, बड़ा topics complete कर दिया हमने. कल पहले घंटे gate problems करेंगे, old questions, gate old questions, and उसके बाद we'll start the synchronous machine. Right? That's another big chapter, in fact. Synchronous machine, of course, equal to transformer. Then the final one is induction motor. Last one I'll start induction motor. Okay. Just let me know if you have any doubt. Otherwise, I'll wind up the session for the day. Tomorrow we'll start anyway. Gate questions. You have any doubts? Anchal, Bhaskar, Shabikant, Injil. Yeah, no good, Injil. Then Shabikant, nice. Yeah, we'll solve more tomorrow, more problems on this, Bhaskar and others. Okay then. So thanks for joining then. Thank you. Thanks very much. Yeah, thank you, Shabikant.